Today's video is on the 6 trig ratios. The 6 trig ratios are listed in these two boxes here. We have sine, cosine, tangent, cosecant, secant, and cotangent. We'll talk more about those in a second about what they are equal to. The acronym SOHCAHTOA is used so you can easily remember how to define sine, cosine, and tangent. So these ratios help you find missing lengths of a right triangle. The sine of, this is called theta, T-H-E-T-A. The sine of an angle, theta, they're saying it's right here, is equal to OH. That could be the same as the opposite divided by hypotenuse. So you're going to go to the angle, theta, and the opposite side, you're going to put on the numerator, and you're going to divide it by the hypotenuse, which is always across from the right angle. The cosine is given from the name co, which is complement of the sine. That's how they got the name cosine, the complement of the sine. And you can define that as theta is the adjacent A over H. Adjacent divided by the hypotenuse side. Again, we use these six trig ratios to find missing side lengths or a missing angle. So that's what the A and the H stood for. Take the adjacent and divide it by the hypotenuse. The third trig ratio is tangent, and that could be defined as the opposite, O, divided by the adjacent. So the opposite side of theta divided by adjacent. Adjacent means next to, so the side next to theta, that's not the hypotenuse. The three trig ratios on the right side are reciprocal functions. Remember back to Algebra 2 or Algebra 1, reciprocal means flipped. So what you're going to do is take each corresponding original trig ratio and you're going to take the reciprocal or the flip version of the new trig ratio. So sine, the reciprocal, is cosecant. I'll write that up here, cosecant. That's what the CSC stands for. And the reciprocal is the hypotenuse, the flipped, divided by the opposite side. SEC stands for secant, or the complement of the cosecant. And if we take the reciprocal of cosine, it's going to be hypotenuse divided by the adjacent. COT is cotangent, or the complement of tangent, and that reciprocal function is the flipped of tangent, adjacent divided by the opposite. You don't have to memorize all six. If you basically memorize the first three, sine, cosine, tangent, from SOHCAHTOA, you then can infer the cosecant, secant, and cotangent by taking the reciprocal. Let's apply this to a couple examples. First example, let's find all six ratios of theta. Here's theta right here. It's given by 30 degrees. The first three we're going to do are sine of theta. We're going to do cosine of theta, and we're going to do tangent of theta. Sine is defined as the opposite side 1 divided by the hypotenuse, which is 2. So the sine of theta is 1/2. The cosine of theta is defined as the adjacent square root of 3 divided by the hypotenuse. And the tangent of theta is the opposite divided by the adjacent. Do something more with this right here after we finish the other 3 trig ratios. The inverse of sine is cosecant, so we don't have to even look at the triangle. We can just take the sine and flip it 2/1, which I'm just going to write 2. The reciprocal of cosine is secant, and I'm going to flip that fraction to 2 divided by square root of 3. I'll do something with that in a little bit. And then tangent, the flipped is cotangent, and I'm going to flip it to be square root of 3/1. I can easily change that to simplify that to square root of 3. Now, I said that I was going to come back to tangent and secant because these fractions are not completely simplified. The reason I say that is because they have a square root in their denominators. The way we simplify these square roots is by what's called rationalizing. And the way we rationalize is we multiply the fraction by 1. So I'm going to take this tangent of theta. I'm going to multiply it by 1. And when I multiply it by 1, I'm going to multiply the numerator and denominator by whatever this square root number is. So in this case, I'm going to multiply the top and bottom by the same number, the square root of 3. And when we multiply fractions, we multiply straight across. 1 times square root of 3 is square root of 3. And if you check in your calculator, square root of 3 times the square root of 3 simplifies to just be 3. Our final answer for tan simplified is square root of 3 divided by 3. Did we know it's simplified enough because there is no more square root in the denominator? Now if we try secant, simplifying this fraction, I'm also going to multiply the top and bottom, the numerator and denominator, by square root of 3 because that's the same number. We know that square root of 3 times square root of 3 makes a normal 3. 2 times square root of 3, we're just going to leave that as 2 radical 3. When we multiply a normal integer times a number inside a radical sign, just put them right next to each other. Another way to think about that is if we're multiplying, let's say, 2 times x, we don't really do anything with it. We just take it and put them right next to each other. So when you multiply square root signs, treat it like a variable, and you cannot combine it with that normal number. Just do one more of these 2 examples. Let's do this second example here. Find all 6 trig ratios. I want you to try to pause the video and find sine of theta, the cosine of theta. In this case, it's going to be f. So I can erase sine, I can erase thetas. So I'm going to do sine, instead of theta, I'm going to do sine of f, cosine of f, tan of f. I'm going to do reciprocal functions as well. Cosecant of f, secant of f, and cotangent of f. So try pausing the video and find the simplified answers, simplified ratios of those and see what you get. These are the answers I got. I started with sine, cosine, tangent, and then I found their reciprocals, and make sure you simplify your fractions. Have a great night, guys, and see everyone next time.